Let's do a summary for the RL circuit and RC circuit. And we compare the RC circuit and RL circuit side by side. And first of all, let's look at the source-free response. In this case, there's no independent source applied to the circuit. The response of the circuit is caused by the initial value on the capacitor or on the inductor. So let's look at the RC circuit. In RC circuit, we always talk about the voltage across the capacitor. In inductor circuit, we always talk about the current flow through the inductor. This is Ohm's law for capacitor. I equals C dV dt, and by duality, the Ohm's law for the inductor is V equals to L di dt. The initial value, the voltage at t equals 0, this is at t equals 0, equals to V naught. For the RL circuit, the initial current at t equals 0, t equals 0 equals to I naught. And we know at time t equals 0, the energy stored in the capacitor is half CV naught squared. The energy stored at the inductor is half L I naught squared. For RC circuit, we apply KCL. For our RL circuit, we apply KVL. And then we obtain V of t equals V naught e to the power minus t divided by tau. And for our L circuit, we obtain I of t equals to I naught e to the power minus t divided by tau. In RC circuit, we talk about voltage. In RL circuit, we talk about current. So this is V naught and this is I naught. And we have the same exponential here, but with different tau. Tau is the time constant. In RC circuit, tau equals to RC. For RL circuit, tau equals to L divided by R. As time goes to infinity, the energy will be absorbed completely by the resistor here. So this is R. The energy absorbed by the resistor as a function of time for RC circuit, that's half CV naught squared and 1 minus e to the power 2t divided by tau. And for RL circuit, the energy absorbed by the resistor is half L I naught squared. That's the same quantity here in both cases. When time goes to infinity, the energy absorbed by the resistor will be the same as the initial energy stored in the capacitor or the inductor. Now let's do a summary for the step response for our RL circuit and RC circuit. This is column of RC circuit. This is a column of RL circuit. The power supply is Vs multiplied by U over T. So this implies that at t equals 0, the voltage is applied to the circuit. The same thing here for RL circuit. At time t equals 0, the voltage is applied to the circuit. The response for the voltage at the capacitor is V of t equals to V infinity plus V of 0 minus V infinity multiplied by the e to the power minus t divided by tau, and this is for t greater than 0. For the inductor, we said RC circuit, we talk about the voltage across the capacitor, and for our L circuit, we talk about the current. So I of t equals I infinity multiplied by I0 minus I infinity multiplied by e to the power minus t divided by tau. And tau for our RC circuit equals RC, for our L circuit equals to L divided by R. So V infinity, that's a steady response of the voltage when time goes to infinity. So in this case, we can see when time goes to infinity, the voltage across the capacitor is equal to Vs, because the capacitor is treated as open circuit here now when time goes to infinity. At time goes to infinity for the inductor is short circuit. the current is Vs divided by R. Again, this is Ohm's law for the capacitor. This is Ohm's law for the inductor. Now, if we look at time t equals t naught, the switch close. Instead of t equals 0, we t naught may not equals 0. This is a general case. This is the same thing at t equals to t naught, the switch closed. There's a voltage applied to this circuit here. There's a voltage applied to this circuit. The voltage across the capacitor is this now. Is equals to V infinity plus Vt naught. That's the initial voltage at t equals t naught minus V infinity, that's steady response, e to power minus t0 and divided by tau. So the time has been shifted. If we compare this case, when this is a t equals 0, and this is a t equals t naught when the switch closed. In this circuit, the switch closed at t equals t naught. So we replace t by t minus t naught, and the initial value becomes Vt naught. The same thing for the inductor. The inductor equals I of t equals I infinity. So the initial value is It naught. The time becomes to t minus t naught in this exponential here. So this is the initial value at t equals t naught.